Good morning, Year 6. It's Friday. Woo, Friday. Just so you are aware what we're expecting by the end of the weekend, can you make sure that we see something for your design for your Anderson shelter, thinking about scale. And also, we'd love to read your poetry from your wall poetry from earlier on in the week. If you decide to write a poem about something else, as long as you've got metaphors and similes in there, and you've thought about the way it sounds, then we'd be happy to read a poem about something else too. You also need to make sure that you have done your maths test today. Now, your maths test for some of you is all about thousandths, and for others of you is all about turning fractions into decimals and the equivalent fractions in decimals. So I'm going to use this video to talk to you about how to do that, to make sure you're all ready for your Friday Maths Challenge. We're going to start with a little recap on tenths, hundredths and thousandths. So if I write a tenth, I write it like this. 1 over 10. 1 is the numerator and 10 is the denominator. But 1/10 can also be written like this, 0.1. And we know that because this 1 is in the tenths column. There is 1 in the tenths column. So 1/10 is the same as 0.1. But I can prove that that's true because I know that a fraction is a division. So 1/10 is the same as 1 divided by 10. Which is written like this, 1 divided by 10. So if we're using the bus stop method, we've got 1 divided by 10. I know it looks strange to have a bigger number outside the bus stop, but that's exactly what we're doing here. We've got the numerator 1, that goes inside the bus stop, being divided by 10, the denominator on the outside, 1 divided by 10. So you can't fit 10 into 1. So if we think about our 10 times table, it doesn't fit. So it's a 0. So we put that at the top. And when we get to 0, we don't just stop. So we have to change the whole number from a fraction into a decimal, no remainders. So 10 into 1, we can't do that. So we put a decimal point and we put a 0 there. Because 1 is exactly the same as 1.0. It's exactly the same number. So now I can do 10 into 10, and that fits 1 time. Don't forget to put your decimal point. When you put a decimal point down here, you put one up here. So we've got the proof that 10 is the same as that 1/10 is the same as 0.1. 1/10 is the same as 0.1. But I can prove this in another way because we know about moving on numbers around the decimal point when we're dividing by tens and hundreds and thousands. So here I've got 1, and when I divide it by 10, I get smaller. So I'm going to move that 1 decimal place over, and I'm going to put in a placeholder. So I have proven that 1 divided by 10 is 0.1. And the same thing works for hundredths and thousandths. So 1/100th is written like this, 1 divided by 100. So I start with my 1, I divide by 100, so I'm going to move it 2 decimal places. So if I've moved it 2 decimal places, I end up with 0.01. But you could also do the same thing. You could use a bus stop method to prove that. And a thousandth. 1, 2, 3 thousandths. So if there's 3 zeros, we're going to move that decimal point 3 times. So the decimal point starts here and it goes 1, 2, 3. We end up with 0.001. That is a thousandth. The same thing. Remembering that fractions are divisions. Now we've got 300ths, so we're going to have the 3 in the hundredths column. We've got 3,000ths, we have the 3 in the thousandths column. But what about if this was 30 hundredths and 30 thousandths? Well, we can do an interesting trick here with equivalent fractions, and I can divide both the top and the bottom by 10. So 30 divided by 10 is 3. 100 divided by 10 is 10. And I can work out that 30 100ths is the same as 3/10, 0.3. And the same thing here. Divide by 10, 30 divided by 10 is 3. 1,000 divided by 10 is 100. So I know that 30 1,000ths is the same as 3 100ths. If you don't believe me, we'll use the moving the numbers around the decimal point method with a place value chart. So we start here, 30 divided by 1,000, 30 divided by 1,000. 1, 2. Now I need to put in a placeholder, 3, 0.03. And when we have a 0 at the end here, we don't need that, so we can take that off. So 0.03, I've proven it is. There are different methods that you can use to convert between fractions and decimals. One of them is to remember that once we get to tenths, hundredths and thousandths, that division is really simple because we can just use that moving around the decimal point. So the first thing we can always do is see, does the denominator fit into a tenth, a 10, 100 or 1,000? Is 10 or 100 or 1,000 a multiple of that denominator? So in this case, we've got 5. Does 5 fit into 10? Yes, it does. So that makes it easy. We can use equivalent fractions. So we can change that 5 into 10. And what did we do to change 5 into 10? We multiplied by 2. So we have to do the same to the top. 3 times 2. And we end up with 6. So 3/5 is the same as 6/10. And 6/10 is 6 divided by 10. And when we divide by 10, we make that number smaller by 1 decimal place. So we end up with 0.6. So we can see here that 3/5 is the same as 0.6. 3/4, let's do that one. Now, is 10 a multiple of 4? No, so we can't use 10. Is 100 a multiple of 4? Yes. 4 times 25. 25 lots of 4 or 4 lots of 25 equals 100. So we can change that into hundreds. We can put a denominator of 100 on the bottom. And we multiplied that by 25. So we have to do the same to the top. 3 times 25, 75. 75 100ths. And we know that when we divide by 100, we're moving those numbers twice. So we're dividing by 100, which means that we get 0.75. Now we'll look at eighths. Does 8 fit into 10? No. Is 100 a multiple of 8? No. Possibly 1,000 is. But I don't know off the top of my head if 1,000 is. So I'm going to use a different method. I'm going to use division. So 1 divided by 8. 1 divided by 8. I can't fit 8 into 1. So I'm going to put my 0 at the top. And when I do that, I have to remember my decimal point. And then I'm going to put my 0 here. So I can carry this 1. So I'm now doing 8s into 10. 8 fits into 10 one time, but it has a remainder. It has a remainder of 2. So I now need to put my remainder. So if I have a remainder, I have to put another 0. So I'm now doing 8s into 20. How many times does 8 fit into 20? Let me see. 8, 16, 24. Okay. Twice without going over. So I put the 2 there, but I still have a remainder. Now I'm not allowed to write remainder in the middle of a decimal. So I'm going to put another 0. And now I have a remainder of, so 2 times 8 was 16. 17, 18, 19, 20. I have a remainder of 4. Let's see. Does 8 fit into 40? Let me keep going. 32, 40. Yes, it does. 1, 2, 3, 4, 5 times. And there is no remainder. So 1/8 as a decimal is 0.125. So if you're not sure if you can change it to 10, if you can find an equivalent fraction that has a denominator of 10, 100 or 1000, then you can use the division method, but don't leave any remainders. So before you go ahead and do your Friday maths challenge, you might want to have a go at some of these to see if you can, they're over here, if you can use division to solve these, or you might use a different method. I've got 7/8, 6/15, 11 quarters. Now 11 quarters is more than 1. So you're going to end up with 1 point something or 2 point something. It's going to be not necessarily a 0 point. A third is a really interesting one. A third, see what happens when you try and divide 1 by 3. Let us know what you find out and how you solved the problem, because it is going to be a problem. What did you do with the answer? Enjoy, and I can't wait to mark your Friday challenge.